Hi Year 12, just a quick look at yesterday's submission task to start with. So you had to solve your simultaneous equations, use your calculator. You didn't actually need the y values. A few of you did, which is fine, that's brilliant. That's completeness, but actually in order to answer this question you didn't. The x values were enough. And there were several ways of solving it, so that wasn't the only way of doing it. You only needed to differentiate the curve because we were only after the gradient of the curve at those points. So that was that. Substitute the values in. Bingo. Okay, on with today. So we have learned how to differentiate. We can work out this formula for the gradient of a curve and substitute in a value of x, and that gives us the gradient at that point. So what? Well, over these next two lessons, I want to look at two really important applications of that. They are the two main applications of it, really, at this stage. There are a few others, but these are the two main ones. And today we're talking about using this to find the equations of tangents and normals to a curve. So what's a tangent to a curve? So that's just a line that touches the curve at one point. And that has a particular significance if we're talking about something in motion, because that line can sort of model the motion of a particle at a particular instant, and if for whatever reason this is a particle moving and it gets released from whatever's holding it in that path, that's the way it will travel. So these lines are tangents to the curve. We've used the word tangent before. The normal to a curve, well, if I draw the tangent to the curve at that point, the normal to the curve is perpendicular to that. So that's the normal to the curve. So it's perpendicular to the curve at that point, and that's of particular significance with a circle because the normal to the curve at a particular point is a radius or a diameter. Although of course I have pointed out that we don't, until year 13, we don't learn actually how to differentiate the equation of a circle. So anyway, today we're looking at finding the equation of tangents and normals to a curve. And we've done, we've worked out the equation of straight lines lots and lots and lots already this year. And we know that to work out the equation of any straight line, I need two bits of information. I need to know the gradient and I need to know a point. And then I go through my three-step process. So in this question here, I've got a point, 3, 5. That point lies on a curve. I want to know the equation of the tangent to the curve at that point. If only I had a way of working out the gradient of the curve at that point, that would be the same as the gradient of the tangent. So the gradient of this line is the same as the gradient of the curve at that point. The gradient of this line is the same as the gradient of the curve at that point. And the good news is, of course, we do have a way of working out the gradient of the curve at that point. We differentiate. So I'm going to differentiate my function. Multiply by the power, reduce the power by 1, multiply by the power, reduce the power by 1, multiply by the power, reduce the power by 1, but we know that just becomes 2. And substitute in my value. And I'm really going to hammer this. I know you could easily substitute x is 3 into that, but I want to encourage you to use the calculator when you can. So I'm going to store 3, and I'm just going to type in 3x squared minus 6x plus 2. Yeah, you'll see why I want you to do it this way, because we get some really weird and wonderful ones. So the gradient's 11. Okay, so I know that the gradient of this curve at that point is 11, so that means the gradient of the tangent at that point will also be 11. So do you remember the process that we go through to work out the equation of a straight line? If the gradient's 11, it's y equals 11x plus something. I then substitute my values in. Remember, that's my x value, that's my y value. So 5 equals 11 times 3, 33 plus c. Take away 33 from both sides. So my final answer is that is the equation of the tangent to the curve at that point. Easy peasy. So why don't you have a go at A, and we'll come back in a minute and do that, and then have a go at C, and then have a go at E. So do A first. I'm going to pause the video and come back with that one, and then C and E we'll do in one go. Pause and have a go. So for A, I'm looking for a gradient and a point. I've got a point, 2, 0. To work out the gradient, I differentiate 2x minus 7, make x equal to 2. 4, take away 7 is minus 3, so that's my gradient. So now I'm just off to the races with my method. So that's what it's going to look like. Substitute those values in. Nice and easy when y is 0, so I've got okay. C and E. C, you've got to remember that before we do this, we need to rewrite this in index form. So that's 4x to the half. Now I haven't differentiated yet, so you've still got to differentiate that. That's just writing it in index form. And then this one, you've got a negative value of x, but if you're using a calculator, no problem. So have a go at C and E, and then we'll come back. So with C, half times 4 is 2, and reduce the power by 1. And, I could, at that point, rewrite that as 2 over the square root of x, or go for my calculator. So I might put 9 as my x value, and I just type in 2x to the power of minus half. Now I'm going to make sure I use the minus button to do minus a half, so that's minus, I could do minus 0.5 or do it like that. And that's interesting, it does it that way. Does it S to D back to 2/3? Yes, it does. There we go. So the gradient's 2/3 anyway. So y equals 2/3 x plus something. These are my values. So 12 is 2/3 of 9 is 6. So y equals 2/3 of x plus 6. That was the answer to C. Sometimes they might ask you to multiply that by 3 and rearrange it. It didn't in this case, but we might have been asked to do that. And then this one here, again, I'm being really lazy because I really want to drill this technique. I'm not doing it because I think you need to do it at this stage. So I'm going to store minus 1 as my x value, and then I'm just going to evaluate 6x squared, 6x squared plus 6, so you get 12. The gradient's 12, so we've got y equals 12x plus something. Going to substitute those values in. So 2 equals 12 times minus 1 is minus 12. So C is 14. So I get y equals 12x plus 14. Now we won't do these three, but you can find them on page 268, and you may well want to do that. With this one, make sure you rewrite it as x plus x to the minus 1 before you differentiate it. And with this one, make sure you write it as x squared minus 7x to the minus 2 before you try and differentiate it. And this one, we haven't come across this yet, but I'll cover it now. You've got two things divided by one thing, so I can write it as two separate fractions. So it becomes, sorry, I'm running out of space here. Where can I write it? I'm going to write it down here. So this is not differentiating, this is just rewriting it. So I could write it as 2x divided by x minus 1 divided by x. There the x's cancel out, so that's 2, and 1 over x. So if you were going to go on and do those three as independent study, then you, before you differentiate, make sure you rewrite that one as that, this one as this, and this one as this. And then they're easy to differentiate. Okay? Right, let's move on to the equation of normals to the curve. So just a reminder that the normal is perpendicular to the tangent. So if I know the gradient of the curve, that's the gradient of the tangent, the normal will be perpendicular to that. And we know, don't we, the relationship between perpendicular gradients. Do you remember it? Where are we? Flip it, change the sign, easy peasy. So let's have a look at an example. Find the equation of the normal to the curve with that equation at the point where x equals 4. First thing I'm going to do before I do any differentiating is I'm going to rewrite this in index form. The square root of x is x to the half. Haven't differentiated, just rewritten it in index form. Now I'm going to differentiate. Great news. Constant terms disappear. So minus 3 times a half, I'm going to write that as minus 3 over 2. Now I could rewrite that. I could. This is minus 3 over 2. This is 1 over the square root of x. So you end up with... And that's useful to be able to do that. But actually, I'm not going to worry about it now because all I'm going to do is substitute in x is 4. And guess what? Ta-da! Here we are. X is 4. I'm going to type in this. So I'm going to do fraction button, minus, using the minus in brackets button, minus 3 over 2. I can do minus and then hit the fraction button if I wish. It's the same thing. Pop out. X to the power of... And again, I could have pressed minus and then the fraction button, or the fraction button and minus. You get the same thing. But interesting, gives it to you as a decimal again. There we go. Now, you know, you could have worked that out, but it's much easier to get your calculator to do it for you, isn't it? So, okay. So, this time we need to be careful at this point, don't we? Because we're being asked in this question to work out the equation of the normal to the curve. This is the gradient of the curve, so that would be the gradient of a tangent. So this plus 4 over 3. Now, the point, I've only got the x value. How do I work out the y value? Well, for that I go back to the original function, not dy by dx, that's how you work out the gradient. When you want to work out coordinates, you go back to the original function. So here we go. I've still got x is 4. Just check it is. Yep, x is still 4. So now I'm going to type in this or this. It doesn't matter which way. It's the same thing, isn't it? I told you how much I love these calculators. There you go. And that's, yeah, historically, that's where people make mistakes. People make mistakes not when they differentiate, but when they substitute values in. So using a calculator removes that possibility. And then it's just substitute those values in. 4/3 times 2, when x is 2, is 8/3. And so I need to take away 8/3 from both sides. I can do 4, take away 8/3 on my calculator, or I can remember that 4 whole ones is 12/3. So, you know, whichever way you do it, you end up with 4/3. So y is equal to 4/3 of x plus 4/3. So some of you might want to do that one. That's a slightly more straightforward one. Some of you might prefer to do that one, which is a slightly more complicated one. I'm going to show the answers to both in a moment, although I'm going to go through that one, but some of you might want to skip that and do that one instead. Make sure you write this in index form before you differentiate. Pause and have a go. Okay, I've set this out in a slightly tragic way. I apologise, I haven't really left myself enough space, but with the first one, differentiate it. Substitute in x is 6, and that gave me the gradient of 7. I could do that in my head, didn't use my calculator for that one, so that's 12, take away 5, so that's 7. So that means the gradient of the normal is minus 1/7. And actually, on reflection, I think it's good to make that extra little thing in your notes just to make it clear that you know you're going from the gradient of the tangent to the gradient of the normal. Okay, so I haven't got room to go through my process here, so I'll do it down here. So I know y will be equal to minus 1/7 x plus something. Substitute those values in. So y is 6 and x is 6. Minus 1/7 times 6 is minus 6/7. And so I'm going to do 6 plus 6/7, which I can do manually, or I can just let my calculator do the hard work. So that gives me 48/7, or 6 and a bit. So I'm going to rewrite it as y equals minus 1/7 x plus 48/7. And I note in the answers in the textbook that at that point they've multiplied everything by 7. Now you don't need to do this unless it specifies they want it in a particular way, but that kills that fraction, doesn't it? And I think they write it something like that. They add an x to do it like that. If you had a go at the trickier one, so before you differentiate, this is 8x to the minus a half. Differentiate, so x squared becomes 2x. Minus a half times minus 8 is plus 4, and then you reduce that by 1. I just used my calculator to tell me when x was 4 what the gradient would be. Left it as a fraction because that's what I'm going to do now. I'm going to flip it and change the sign. And then, yeah, it's not very nice numbers. And again, I note that the the textbook multiplies by 17 at this point, which kills that fraction. And then they shift the 2x over. Okay, good stuff. So a couple of submission questions. You'll find them on in the same part of the textbook. I think they're just over the page, so that would be page 269. But I still like to see them in OneNote, please. And yeah, they're a little bit more complicated, but hopefully you'll be able to work them out. Okay, I will hear you will hear from me again tomorrow. Take care.